Hello there, it's Jerry, and we're in part 3 of basic operations. I still didn't organize the file, so yeah, you can see that. I've commented out everything because we're going to do some other operations and I just need some blank space here, but just bear with me, I will organize this. Okay, so we've talked about, and maybe let's just go through this. We talked about some operations on strings, right? And we saw some difference in precision of the floating point values. Then we did some mathematical operations, a whole bunch of them. Yeah, and we saw the math tool, well, the math class. Yeah, and we used it more or less. Yeah. Okay. Today we are going to learn something. Well, some operators or some operations on logical values. So logical operators or operations, whatever. Yeah. Okay. Logical operations. Okay, so for this, we'll just need a few Boolean values. So usually in mathematics, we just have like P, Q, and will result, right? Something like this. And yeah, and we're just going to see, well, how logical operators work and what logical operators we have there, right? So let's say P is equal to true, right? And we'll start with this. So okay, and Q is equal to true as well. Okay, let's just start with this. True. Okay. So and yeah. So first we'll go with the negation because that's like the simplest one. So let's go with the console right line and then P is equal to P, right? Okay, and then negation. So just copy that, and we'll say not P here, not P. So negation, right? Is just not P, right? And this sign here is the negation. Let me see if I still have the precedence of operators somewhere open. And here it is. Yep. So the logical operators. Okay. Yeah. Okay. I think it's in the unary operator. So this one is actually right to left, right? So first, this expression is evaluated, and we'll see that in a second, right? And then the not operator just negates everything that is on the right-hand side. So we first calculate the right-hand side, and then we just negate everything, right? So that's the unary not. Yeah, because there is nothing else here. That would be this. Okay, let's see the not in action. I hope it works. Okay, so P is true. Not P is false. Very good. Okay, so we have the negation here. Now, let's see the AND operation. So logical AND. I am not sure how it's called in English. I'm sorry. And I don't even know how it's called in Polish, I think. Doesn't matter, right? So P and Q, so true and true, should be true, right? So let's see. We'll say like, okay, P is equal to P, Q is equal to Q, right? And then we'll see, let's just take this one out here. So we'll say P and Q is equal to, and now if we open the precedence, the AND operator is actually here. So we have the AND operator here, right? And that's just 2 ampersands, I think it's called 2 ampersands. Maybe? Yeah. 2 AND characters. So P and Q, right? Okay, so, oh, come on. You stupid. You stupid. Now you should know. Now you should work. Yes, please work. Okay, yeah, I had to put that in brackets because it couldn't figure out a value. Um, because it just took like this p. So okay, I know what to do with this p, but then I can't figure out because it's the AND operator. So this one is left to right. So we're doing like, okay, string, concatenate string with the text value of p, which is true, and then perform a logical AND operation on this. So it was like, what am I supposed to do here? So that's why I needed to do this in brackets, so that it took first this thing in brackets. This is just in mathematics, right? So something like this. Okay, so P is true, Q is true, P and Q is true, right? Okay, and we'll just switch something here. So now P is false, right? So the second one should be like, okay, P is false, Q is true, P and Q is false, right? Okay, very good. And we'll have another one here. So now Q is false, right? Q is false. So P is false, Q is false. So P and Q is both false, right? So it's something like this, right? Yeah. So that's the logical AND. So let's make P and Q both equal to true now again. And this is another thing you can do. This is I like to call it multi-assignment. So I am assigning a value. This is evaluated, let's see the precedence, because I don't want to say something that is not true. The precedence, and just the equality. Yeah, okay. This is the equality sign, and it's right to left. So I'm not going to say something wrong. So because we have the assignment operator here, then we have to calculate everything from the right-hand side. So first, true is assigned to Q, right? Then the value of Q is assigned to P, and so on and so on. So from the furthest right, we go to the left, and keep on assigning, right? So now I just assigned true to both P and Q. This is the same as if I said P is true, right? And then Q is true. Just in one line, and let's code, right? So something like this. And now we'll try to do the logical OR operator. So logical OR. Don't need the operator, right? So we'll use this. Okay. And we'll use the logical OR. So like this, OR, right? And then if we look at the precedence, the logical OR is here, right? So it's a bit below than the logical AND, so it's a bit less important. So the logical OR will be actually performed second. This is something that we need to remember always. But I'll give you an example in a few seconds so that you actually understand this. And this will be really, really, really important when we jump into conditional statements. And, well, yeah, and then more programming. So logical operations are very, very important. Okay, so let's see what's the result here. So, and yeah, maybe, I'm sorry, we'll jump back to that. We'll have these commented out because it's getting messy on the console, and I just want to have as few things as possible. So now, P and Q are both true, and P or Q is true, right? So let's make the next one again. So we'll make P equal to false, right? And then test this one out. So P is false, Q is true, so P or Q is true, right? And we'll do this the opposite way around, so Q is true, P is true, P is true, and Q is false. And now I'm doing another thing that I can, because statements in C# don't really have to be in separate lines. I can just keep on saying like right line, right line, right line, right line, and just move along the line. But for convenience, we actually put one statement in one line so that it's more readable. But sometimes when you want to assign values and there are short assignments, and you just keep them in one line just to save some space and then just to have everything being a bit more readable. So this is the reversed example from the previous part, right? So we had P being false and Q being true. Now this is the other way around. So P is P is true and Q is false, right? And P or Q is true. Yeah, you should know this from just simple mathematics. Now let's just make both false, right? So let's copy this, yeah, make them false, and then copy this and see what's the result here. So now they are both false, and when they are both false, then they are both false, right? Yeah, so this is quite simple. Okay, we have another one, and it's called the logical XOR, and we had this earlier somewhere. So yeah, when we were trying to find the power. But this is bitwise. Oh. Okay. Give me a second. I'll try to figure out the exclusive OR. Okay. Okay. So I consulted Uncle Google and figured out this my way a bit, and then Google helped me a bit. So yeah, in general, the XOR operation is the same as not equal, and let me show you this example in Excel, because I just created all the pairs of P and Q having values like true and false. So, and I have this XOR operation in Excel, right? So whenever both are the same value, doesn't matter whether it is true or false, then XOR is false. Now, if either is true or false, then the result is true. So this is actually the same as saying this equal to this, and then having this not here, not, right? Something like this. Okay. So P not equal to Q. That's not true, and it's false. P not equal to Q, that's true. P not equal to Q, that's true. And P not equal to Q, this is false, right? So actually, not equal to XOR, actually. And then we can write that. So, and we'll just write all the possible things. So, like this, like this, like this. Yeah, go on. And then we'll keep on. Yeah, you can do it by yourself. But I'll show you how it's how to show the not equal, right? So if P and Q are true, then this is this, and we'll just all the four. So here we have like P is false, like here. Yep. And then we have the other way around. And then with the false. Right, okay. Let's have this commented out so that we can see only the XOR operations. Okay, so that's how it is here. And I messed something up, right? Both, yeah. Did I mess something up? false, true, true. Oh, okay, no, I didn't mess up. I just couldn't see this. So look at this. So, okay, both are true. So this is false. Let's make this a bit shorter. It's hard for me to do this. Okay, so both are true, then this is false. One is true, the other one is not. That's true. One is true, the other one is not. That's true. Both are false. That's false. So that's the XOR or not equal to. Right. Okay. So now maybe let's complicate this example a bit, because I said like, well, you should think about the precedence, so that the AND operator is more important than the OR operator. So we'll have now another Boolean operator, Boolean variable, so P, Q, and then just have the R here as well. Okay, and now let's comment this one out as well. Right, and comment these maybe so that we can set the values as we want. So, okay, P is true. Okay, and Q is true. Is true, come on. And then R is false. Okay, and we'll be performing. So let's copy this and then add R here. Okay, so class and R is equal to R, right? And just for convenience, we'll have this /R/n just to have this more separated, right? Okay, so now we'll have another one, right line, and now we'll say like, okay, P and Q or R, something like this. So some more complex logical expression, and we'll write the same thing here. So we need to put that in brackets. We know that from the previous examples, right? So P and and now in additional brackets Q or is this double R or R, right? And let's see what's the result of this. Okay, so and now let's evaluate this in our heads. So if we look at the precedence, right, AND is more important, so we have to perform AND before we perform the OR, right? And what's the sidedness? Okay, both left-sided, so that we perform from the left. So AND is more important, so we just go on. So oh, and we have this bracket here. The bracket means that we need to perform this first, right? Okay, so maybe I did it a bit wrong. We'll remove the bracket in a second. So I have to do this first. So Q or R, Q is true, so that's true. So true and true, that's true. Okay, let's remove the bracket. So we remove this bracket, so we don't force it. And then, okay, the result is true. And I remove the brackets here so that you have it as well. Okay. So, oh, come on. Move. Okay, so P and Q, so true and true, that's true. And true and false, that's false. Okay, let's reverse the order. So we'll take this, right? And then we'll say like first R or P and Q, right? If we reverse this order, yeah, and I said R or P and Q, right? Something like this. Okay. And if we look at this, then this is again true, right? But now we actually have to do P and Q and then the OR, right? So we actually do the same thing. So these are actually the same, irrespectively which one we do. Okay, but what happens if I say that P is false? Right? So R is false and P is false. What happens here? False. Right? Okay. Now the whole thing is false. Why? Okay. P and Q, that is false. Okay, that's cool. P and Q, that is false because P is false and Q is true. So that is false. And false or false is false. Okay. And if we do another thing, let's say R is true. Yep. So, yeah. Now we have what? This whole thing is true because what we do, P is false and Q is true, so that whole thing is false. But R is true, so R or whatever here, that'll be still true. Okay, and now, yeah, so we have some more complex things. And now let's include some mathematical operations here, right? So we will have int v1. I just don't want this to actually mess up with the things that we have already above, and we have something to be organized. So yeah, so we have v1 equal to 4. Let's say like this, right? And then we'll use P equal to true, and then so P is true, right? P is true, and then we'll say console write line, and then we'll say okay, P or, and then we'll have this v1 plus plus equal to 5. Okay? Well, actually like this. Okay? We'll try to write that. We'll see how it works. So v1 plus plus equal to 5. And yeah, we need to put that in brackets, of course, because we want to make that an expression. Yep. Okay. Should work. Okay, so we have the logical value of P being true. And then we have an OR. Let's look at the precedence here, because this is a bit complicated. So now check if it's equal. This has a higher order of precedence, so we have to, it's even higher than the AND, so we have to check the equality first, right? And then we know that this is postfix, right? So we know that this will not increment, so this until this whole expression gets evaluated. So this is not equal, so that's false. And this is true, right? So the whole expression should be, in theory, true. Let's see if it works. Yeah, okay, it works. You have this true. I should have put, maybe I'll put a tab here, I'm sorry. Another special character for you, a tab. Yeah, so this will create a tab, and that will actually help us actually look at this, right? So P or this v1 increased in post incremented, check if it's equal to 5, and this is not equal to 5, but P was true, so the whole expression is true. Now what I want to show you is something cool. What is the value of v1? and we'll see like v1. And what do you think will be the value of v1? Well, I am actually curious because it depends on a lot of stuff. I hope it will work. Yes. Okay, I'll give you a moment to think. What just happened here? Because maybe let's put this. Okay. Before we do anything, right? V1 is equal to, and you'll see what it is equal to, right? So like this, maybe. Right, so before we do anything, v1 is 4, and p is equal to true, and we know that this is true because p was true, and we evaluated everything, and we was like thinking really hard how to do this and stuff, and blah blah blah. And v1 is still 4. Okay, maybe you say like, this is because this plus plus here. Okay, yeah, okay, let's change the plus plus. Maybe it's because of this. Okay, so no, it's not. Yeah, I can move this so it's like this. Still doesn't work. Okay, why? Now the simple explanation is that your computer, my computer, and computers try to simplify things so that the calculations are done faster. This means that if you look at the table where you have the OR operator, let me just fix that one really quickly. Okay, so look at this. Whenever P is true, the expression, the whole expression, is still true, so there is no sense in evaluating Q. When P is false, then we actually have to evaluate Q because it might be false. Right? So that's the explanation, and that's why, because P is true, then we have to we don't evaluate the right hand side of the whole expression because P is already true, so we don't need to evaluate this. This means that this is never incremented, and this is never actually being yeah, right? So yeah, even though this should be done first, right? But and well, in this precedence, right, you can see like the OR should be less important. At least that's how I understand this. Maybe I should read this through. The order this thing from the highest to lowest. Okay, from the highest to lowest. From the highest to lowest. So these are the highest. So evaluated before. So we see like the multiplications. Yeah. So that's how I understood the table, and I think I understood it correctly. So even though the logical OR is like below the checking whether something is equal or not, so below equality, it still kind of like forces this not being even evaluated, right? But this is something really curious, and I hope you remember this when you start programming, because this is one thing that really sometimes might just blow your mind, and it's like, what is going on? Why is my program not working? Okay, so I think this is more or less everything I could do with mathematical operator with logical operators, or basic logical operators. So let's just wrap up this video. Thanks for watching. If you have any questions, don't mind and leave a comment or something. Have a good day. I hope you had fun. I did for sure. So see ya.